Here we look at breadth first search traversal of a graph. As a graph is a nonlinear data structure, there are two suggested traversal methods like breadth first search and depth first search. These are similar to tree traversal methods. How they are similar to tree traversal methods, I'll show you. Let us start with breadth first search. See, the breadth first search is similar to level order of a binary tree. But here we may not get a binary tree, just we get a tree. So whatever it is, breadth first search is same as level order. How it is same as level order, let us understand this. I have an example graph taken here. This graph, I can convert it in the form of a tree. How? See, a graph without any cycle or without any closed edges is a tree. So let us prepare a tree for that graph. So I'll show you here. The vertices are 1 to 7. So I'll start from vertex 1. This is vertex 1. Now to a vertex 1, the connected vertices are 2, 3 and 4. So I'll take all. So first is 2, then second is 3, then 4. So for vertex 1, 2, 3, 4 are completed. Now let us see who are adjacent to 2. Who is adjacent? Only 3. So actually I am preparing a tree. So this edge if I include, it will form a graph because it will form a cycle. So what I'll do is I'll put a dotted edge, just a dotted edge. So I have completed these 3 edges plus this one. Now next we have 3 also. So who is adjacent to 3? So from 3 I can go on 5 as well as on 4. So a new vertex is 5. I can go on 4 also. So I'll draw a dotted edge because 4 is already there. Then next from 4 where I can go? 1 that is already over, 3 already over, then 5. So 5 already is there. So I will draw dotted edge. The next is 5. From 5 I can go on 6 and 7. So I will draw here 6 and 7. That's all. I have converted a graph into a tree. I should not say binary tree because this node is having 3 children. So it's not a binary tree, just a tree. Now in this tree, if you observe, I have all 7 vertices. Then if I count the edges, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have all the 9 edges. And I have dotted those edges which are trying to form a cycle. Now if you hide those dotted edges, it's a tree. So I have formed a tree for the graph. Now take the level order. First vertex is 1. Then next level is 2, 3, 4. So 2, 3, 4. The next level is 5. Okay, 5. Next level is 6 and 7. 6 and 7. That's all. This is breadth first search. Then this is the result. Is this is the only result possible? No. When you perform breadth first search, you can get a different results, and whichever result you want, you can take that one. So how different results are possible? Let us see. I will again draw a tree for this one. So I'll again draw from vertex 1. Now who are adjacent? Adjacent to 1 are 2, 3 and 4. Do I have to take them in same order? No, you can take them in any order. So I will change the order now. So first I will take 4, then 2, then 3. So the objective here is you must visit all adjacent vertices of vertex 1. Vertex 1 is the starting vertex. So I have visited all of them. In which order, it doesn't make any difference. So first time it was 2, 3, 4. Now it is 4, 2 and 3. So yes, this order is also correct. Then whose adjacent vertices I should take next? 4s. Who are adjacent to 4? 3 and 5. 3 is already there in the tree. So 5 I should take. So next is 5. And for 3, I'll draw a dotted edge. The next whose adjacent I should take? 2. So for 2, who is adjacent? Just 3. So I will draw a dotted edge. Then next is 3. Who is adjacent to 3? 4, which is already there, and 5 is already there. I'll draw a dotted edge. Then next for 5, who are adjacent? 6 and 7. So do I have to take them in the same order, 6 and 7, or you can change the order? You can change the order. So I will take first 7, then 6. Then from 7 and 6, there are no other edges. That's all. Then what is the level order of this one? So breadth first search is first 1, then 4, 2, 3, 4, 2, 3, then 5, 5, then 7, 6. This is the breadth first search. So this breadth first search is also correct. So yes, for a graph, there can be various breadth first search possible. Like if you see here, instead of 4, 2, 3, I could have taken 4, 3, 2 also. Yes, I'll get a different result then. This is over. Next. Who is the starting vertex in both these trees? 1. Is it necessary that you start from vertex 1 only? No. You can start from any vertex you like. Shall I start from vertex 4? Yes, you can start from 4. So I will draw it. 4 is the starting vertex. Who are adjacent to 4? 1, 3 and 5. In which order I can take? I can take them in any order. So first I will take 5, then 1, then 3. Then whose adjacent I should take? 5. For 5, 3 and 6 and 7 are adjacent. So 3 is already there. So 6 and 7. So I will take first 7, then 6. Okay, no problem. I can take it. Then whose adjacent I should take? 1. So for 1, who is adjacent? 2 and 3. So for 1, 2, I will draw it. 3, it's already adjacent. Then for next 3, who is adjacent for 3? 2, 5 and 4. So 4 is coming from 2, I should draw an edge, right? 5 already there is an edge. That's all. Next, I should go to adjacent vertices of 7 and 6. So there are no adjacent vertices of 7 and 6. I got this result. The tree is different. Starting vertex is 4. So what is the breadth first search for this one? Let us take level order of this one. First is 4, then 5, 1, 3, then 7, 6, 2. This is the level order. So these are the 3 examples I have shown you. Now let us summarize and understand what is breadth first search. Now listen carefully. Breadth first search says that you can start traversal from any starting vertex you want. It should not be or need not be vertex 1 only. You can start from any vertex. That's the first point. So I have started from 1 also, 4 also. I can start from 3 also. Then second thing, when you have visited a vertex, you should explore that vertex completely. What does it mean by exploration? See, when we have selected 4, then we have visited all adjacent vertices. So visiting all adjacent vertices is exploration. So whenever you select any vertex, explore all its adjacent vertices. Then select the next vertex and explore all its adjacent vertices. Then, while exploring, what should be the order of visiting the vertices? You can visit them in any order. Like for any vertex, there are more than one neighboring vertices. You can visit them in any order. So this is the idea about breadth first search. Now let us learn breadth first search freshly as it is found in the textbooks and everywhere. How it is defined, the same way I will define and explain you. See, breadth first search can be defined by using 2 terms. First term is visiting. Visiting a vertex means going upon a particular vertex. This is the first point. And the second thing we should understand is exploring. Exploring means exploration of a vertex. If I say, if I am on vertex 4, exploring vertex 4 means visiting all the adjacent vertices of 4, like 1, 3 and 5. Visiting all adjacent vertices of vertex 4. So exploration means visiting neighbors, and visiting means just going on that vertex. So these are the 2 terms I'll be using for explaining breadth first search. So let us start performing breadth first search upon this graph. First thing, from which vertex you want to start? You can start from any vertex. I will start from vertex 1. Vertex 1. So vertex 1 is visited. So here I will write down visited vertices. This is 1. And this visited vertices, in which order they are visited, that gives me breadth first search. Then I need one more thing. I need queue data structure. So I will take a queue. And I will drop that 1 in the queue. This is the initial point. Select the starting vertex, visit it, and also drop it in the queue. Now whatever I am showing you is repeating. This was the initial one. Now the steps are repeating. Look at this. Take out a vertex from queue. Okay, take out a vertex and explore that one. So start exploring 1. Who are adjacent to 1? 2, 3 and 4. In which order I can visit? You can visit them in any order. So I will first go on 2. 2 is visited, insert it in queue. The next is 3. 3 is visited and insert in a queue. The next is 4. 4 is visited, then inserted in a queue. Now 1 is completely explored. So once you select a vertex for exploration, explore it completely. This we have done. Now again repeat, select a next vertex for exploration. From where? From queue. So in a queue, next vertex is 2. Start exploring 2. So from 2, what are the vertices that I can visit? Only 3, which is already visited. So just draw a dotted line. So 2 is completely explored. So next, select a vertex from Q and start exploring it. 3. From 3, what are the vertices that I can visit? I should explore 3. So 2, 4 and 5. So 2 is already done. 4 and next is 5. I'll draw it like this. So 5 is a new vertex visited and inserted in a queue. Now 3 is completely explored. Select the next vertex for exploration. 4. Who are adjacent to 4? 5 and 3 that are already visited. So just 5 dotted line. Now 4, there are no new vertices from 4. So 4 is completely explored. Now next vertex from the queue. 5. Who are adjacent to 5? 6. Visit 6. Add to the queue. 7. Visit 7, add it to the queue. Now 5 is completely explored. Next vertex for exploration, 6. Nobody is adjacent to 6. So 6 is completely explored. We don't say it cannot be explored. We say it is completely explored. Next vertex from Q, 7. 7, there is nothing adjacent to 7. So 7 is also completely explored. Q became empty, breadth first search ends. And the result of breadth first search is 1, 2, 3, 4, 5, 6, 7. This is one of the result. As I said that when I am exploring vertex 1, 2, 3, 4, even I can change the order. So if you change the order, you get different breadth first search. And it is valid. So for a given graph, there can be various breadth first search. Importance is not the order in which you are visiting. Importance is that you are visiting all the vertices. That is more important. So that's all. I have given you one example and already I have shown you how the various examples are possible. Then learn few things from this one. This tree is called as breadth first search spanning tree. It is a breadth first search spanning tree. And these dotted edges what I am drawing, these can be called as cross edges. These cross edges in a breadth first search tree will be connecting from one vertex to a vertex in the next level only, not far away vertices. You will not find edges connecting from 2 to 6. No. If there is any cross edge in a breadth first search spanning tree, it will be connecting two vertices with the adjacent levels. That is one level to very next level only. So that's all about spanning tree. Now the next thing, how much time it has taken? Let us do analysis. See the time taken for performing breadth first search. So what is the work we are doing? Analytically we are looking at, right? Analytically. The work we are doing is we are visiting all the vertices once. So how many vertices are there? N vertices are there. So the time is order of n. That's it. Then how about inserting and deleting in a queue, and also we are checking whether a vertex is visited or not. More than one vertices are processed here. We ignore them. Analytically we ignore them. We say the time is order of n. So analytical time for breadth first search is order of n. That's all. Next I will show you few valid breadth first search without drawing any tree and all. Just I will write down few breadth first search so that you can understand all these are correct. First one, I'll start from vertex 1. Okay, vertex 1. Then explore vertex 1. 2, 3, 4. No, I will take 4, 3, 2. First 4, then 3, then 2. 1 is completely explored. I should explore 4 now. From 4, 3 is already done. 5. Okay, next is 5. So 4 is completely explored. Now start exploring 3. From 3 to 5, which are already there, then 3 is completely explored. Explore 2. There is nothing nearer to 2. So explored. Then from 5, 6 and 7. 6 and 7. No, I will visit first 7, then 6. Okay, no problem. You can take first 7, then 6. 5 is explored. Now explore 7. There is nothing adjacent to 7, so 7 is explored. There is nothing adjacent to 6, so 6 is also explored. There's one answer. Then, second one. I'll start exploring from vertex 5. Okay, start from 5. Visited. Explore 5. Who are adjacent? 3, 4, 6, and 7. So I will take 7, 3, then 6, 4. Okay, 6, 4. Then 5 is completely explored. Explore 7. There is nothing adjacent to 7. Then explore 3. For 3, adjacent vertexes 2 and 1. So 2 and 1. Now actually I have finished with all the vertices. I can stop now instead of continuing because total 7 vertices are there. All 7 vertices I got. So I can stop it here. As I am doing it manually, I can stop it. Otherwise, for every vertex, it should be checked. Next, third one. I'll start from vertex 2. From vertex 2, first visit vertex 2. Start exploring 2. Adjacent vertices are 1 and 3. I'll take 3 first, then 1. Okay, valid. 2 is explored. Now start exploring next. Which one? 3. From 3, 4 and 5. So I will take first 5, then 4. Okay, 5, then 4. No problem. 3 is explored. Now start exploring 1. From 1, 2 and 4 they are already visited. So 2 and 4 visited. So 1 is already explored. Then 5. Who are adjacent to 5? 6 and 7. I'll take 7 and 6. Okay. So 5 is explored. Now start exploring 4. There is nothing adjacent. Already they are visited. Then for 7, nothing adjacent. 6, nothing adjacent. So I got this answer. So 1, 4, 3, 2, 5, 7, 6 is correct breadth first search. 5, 7, 3, 6, 4, 2, 1 is also correct. Even 2, 3, 1, 5, 4, 7, 6 is also correct. The differences are the starting vertex is different sometimes and the order in which the vertices are explored or visited, that is also changing. So all these are valid breadth first search for this graph. So that's all about breadth first search. Next video we'll look at an algorithm for breadth first search.